Okay, so a very good afternoon to you all, and good morning to you, Dr. Bernard Nongpo. I'm Melvin Esmajau, faculty of the Department of Computer Application, St. Edmund's College, will be your host for today's program. At the very outset, on behalf of the organizing committee, I would like to take this moment to warmly welcome all the members present in this webinar. To begin with, our esteemed dignitaries, Brother Raj Narona, Secretary Governing Body, St. Edmund's College, Professor M. Chakravarti, Vice Principal, St. Edmund's College, Dr. Mrs. B.W. Nongbri, Dean, St. Edmund's College, and our keynote speaker, Dr. Bernard Nongpo, who is currently working as a postdoctoral researcher at the University Paris-Saclay, France. He completed his PhD from the Department of Computer Science and Engineering, National Institute of Technology, Meghalaya, India. His research primarily focuses on approximate computing, program analysis, computer architecture, and computer system security. His work can be found at leading software engineering, computer system journals, and conferences, including IEEE TSE, ESEC FSE, ACM Today's, and ACM IEEE memo codes. And a warm welcome to all the participants. The highlights of today's program is the introduction to fuzzing. Software systems often contain security vulnerabilities. Now we have encountered all of these problems, and we have uh, experienced it in our day-to-day life, and which is the cause root of cybersecurity threats. So to find such security issues, researchers have introduced numerous techniques, out of which we can say that fuzzing is one of the most useful ones. So this talk is intended to give the audience an introduction to fuzzing, and also to explore the state-of-the-art fuzzing to improve software bugs discovery in the target applications. So therefore, on account of security vulnerabilities in software system, the department felt it is necessary to share some light to help create an awareness among the students and faculty of St. Edmund's College, and also the public in general. So before moving ahead towards the program, I would like to take this opportunity to request our Dean, Dr. Mrs. P.W. Nombri, to bless this time with an invocation prayer. Ma'am, if you may. Ma'am, can you kindly unmute yourself? Dean, ma'am, can you kindly unmute yourself and bless this time with your invocation prayer?
Sir Melvin, it looks like you have to give permission to unmute for the participants.
Okay, sure. Just hold on. Okay, I'm so sorry, ma'am. I think so you can now unmute yourself.
Fine. Okay, I'm here for the invocation prayer. Good afternoon, everyone. At the moment, before the invocation prayer, let us all bow our heads and pause in the silence of God's holy presence. Our loving Heavenly Father, we, the faculty and students of St. Edmund's College, Shillong, come to submit into your loving hands this webinar program, Introduction to Fuzzing, organized by the Bachelor of Computer Applications Department. We pray for your divine guidance through this virtual session and bless us all with minds that can understand and thus be benefited from this academic exercise. Lord, we take this time to pray for your blessings on the management of the college, for Brother Raj Naranha as the secretary, for Dr. Sylvanus Lamare, our principal, for Dr. Manatosh Chakrabarti, our vice principal, for our IQAC coordinator, Dr. Brother Simon Coelho, and all those who shoulder other offices of responsibilities in the college. We pray for your blessings on the teaching faculty, office staff, and all workers in the college who work to ensure as best as possible that all our students are nurtured in a holistic way. Our God, as we are going through these difficult times of the onslaught of the COVID-19 and its many variants, we especially pray for your care and protection and for your gracious mercy on our state, our country, and indeed the whole world. This afternoon, as we come before your throne of grace, we pray specifically for the teachers of the Bachelor of Computer Application Department, for Ms. Sharmista Dev as head of the department, for Ms. Rima Joshi, Ms. Rajni Karim, Ms. Sunila Thapon, Mr. Melvin Majau, that dear God, you will bless them in their personal lives and as teachers in the department. Bless them, Lord, in all their endeavors. We also pray for the resource person of this webinar, Dr. Bernard Nongpo. Lord, give him the needed wisdom to give us valuable information, insights, and advice on how best we use our knowledge of technology for the good of this human society. Father in heaven, life is becoming more and more mechanized and digitalized, and we all need to be adequately equipped with knowledge in order to face and overcome the many challenges and demands that come our way while in this life. We pray that the outcome of this session will be that all participants that are present here will understand and practice the good advice and the suggestions that will be given. Thank you for hearing and answering our prayer. Ask in Jesus' name. Amen.
Thank you, ma'am. I will now like to call upon Professor Manatosh Chakravarti, Vice Principal of the college, to deliver the introductory remarks in the program.
Thank you very much, Professor Melvin. Thank you, the entire department of computer application, for having invited me for this afternoon's webinar. It will not be an understatement if I say that I know very little about computers. And the title of this webinar is something that is a little curious as far as I'm concerned, because the word fuzzing has been used. I don't know the technical meaning of this word fuzzing. For me, fuzzing remotely associated with scientific notion as far as I'm concerned. Fuzzing relates to doing a disappearing act, maybe. I don't know. Fuzzing also relates to, once again, in a scientific context, fuzzing for me relates to a blurred image. From a literary point of view, because I'm a student of literature, fuzzing reminds me of the Song of the Solitary Reaper, a poem written by John Keats called Meg Merrilies, where the fuzzing hair, fuzzing in that sense was associated with uncontrollable hair blowing in the wind and all that. So I'm curious to know about this fuzzing in the context of this webinar this afternoon. So I'll be keenly following the points made in this webinar by the distinguished resource person who is consented to be giving this lecture, to have given this lecture. So really, just a few words of acknowledgement for the Department of Computer Application. Here is one department which has made every single Edmundian proud with a kind of professionalism, with a kind of work ethics they have been following right from the time they were, conceptualized as a department in our college. Students have never been in short supply as far as this department is concerned, and the results as well as the other achievements of the department are many and frequent. So it's no surprise that they come up with such wonderful initiatives every now and then. Grateful as a colleague and as the vice principal in my capacity as an administrator working in tandem with everyone in the college, I must say that the Department of Computer Application has really been lived up to its reputation as a department which deals with application-based learning. We are really, really proud. And the other computer department, the parent department, if I may say so, from where it was, it was started initially. They are all very, very hardworking people. They are making a very, very solid learning process and everyday reality for everyone concerned. We personally have benefited from this department when we learned our own, initial lessons in computer when ICT became a reality in higher educational sector in our country. We are grateful to each one of you, those who had started the department and those who are part of the department at the moment. Please keep doing the good work that we have been doing all the time. I have my best wishes for the remainder of the afternoon, particularly looking forward to our resource person, Dr. Barnett. Thank you very much, everyone. All the best.
Thank you so much, sir, for your word of appreciation. Definitely, we, as a department, we will be working towards the greater good of the students and the college as a whole. So now I would like to take this opportunity to call upon our Secretary Governing Body, Brother Raj Narona, to address the audience.
A very good afternoon to all the participants. Bernard, our resource person, and the members, the faculty of the BCA department. This morning, when I sat down and made out a rough plan about my schedule and my engagements, I noticed that I was required to say a few words during this webinar on introduction to fuzzing. Now, I've heard about fuzzy logic, but this was the first time I heard of this word fuzzing. So, like good people and a good person, I went to my Encyclopedia Britannica, which is Google, and I put in this and I said, oh, here's a topic I know nothing about. And I consider myself to be up in computers, etc. So I must congratulate the BCA department for organizing this. I must say that I hope to learn something because it's absolutely new to me. And a very big thanks to Dr. Bernard for joining us. So God bless and have a good afternoon. I shall be with you.
Thank you so much, brother. Yes, definitely. We hope that the students and also the faculty member will learn something new in this session. So now we have, I would like to request our head of department, Mrs. Sarmeshtade, to kindly give her speech.
Respected Secretary, Brother Raj Narona, Vice Principal, Professor Manotosh Chakravarti, Dean, Dr. Mrs. B.W. Nongri, our distinguished guest, Dr. Bernard Nongpo, my fellow colleagues from various departments, and my dear students. A very good afternoon to everyone. Dear participants, it's a great pleasure for me to welcome you all to this webinar on Introduction to Fuzzing, organized by the Department of Computer Application in collaboration with IQSC St. Edmund's College. It's a great pleasure for me to introduce our prominent guest speaker, Dr. Bernard Nongpo, who is a postdoctoral researcher at France, and he has also completed his PhD from the Department of Computer Science and Engineering, NIT Meghalaya. Thank you so much, Dr. Bernard, for giving us your valuable time. Cybersecurity needs no introduction in today's day and age. In the world of cybersecurity, fuzz testing is an automated software testing technique that attempts to find hackable software bugs by randomly feeding unexpected inputs and data into a computer program in order to find coding errors and security loopholes. The world's biggest companies like Google uses fuzzing to check and protect millions of lines of codes in Chrome. Microsoft uses fuzzing as one of the stages in its software development lifecycle to find threats and improve the stability of its products. Dear participants, this webinar is looking forward to gain knowledge from an expert from the field of computer science and also to create a greater awareness on the threats of cybersecurity in computer science. Without further ado, with great pride and honor, I, on behalf of the Department of Computer Application, St. Edmund's College, heartily welcome Dr. Bernard Nongpo this afternoon to this webinar. Thank you, and over to you, Professor Melvin.
Thank you so much, ma'am. Now we have come to the main part of the program, that is to hear what Dr. Bernard Nompa have to share with us in this afternoon. So I would like to hand over this session to you, Dr. Bernard. You may kindly take the session.
Okay, so Professor Melvin, thank you very much for the introduction, as well as to the Vice Principal, the Dean, the head of the department. Is it the screen visible to everyone?
Yes, doctor, it is visible.
Yes. Okay, so I am Bernard Nongpo, a postdoctoral researcher at the University of Paris-Saclay, and I am in one of the lab called CA-LIS, which is a French Alternative Energies and Atomic Energy Commission, and I am in the Technological Research Division. So CA is one of the research center which is associated with the University of Saclay. They have research center for atomic, for computer science, for energy, for almost all fundamental science. So the content of this talk is, I'll start with the context of what is it, like what is security, software security in general. Then I will look into the motivating example so that I can motivate you why you need to learn, or why if you are interested to learn software security. And I will go into the background details a little bit so that you have the general context of what I'm going to deliver you. And then what is software testing in general. And finally, we'll look into the fuzzing. So the context, why do we care about software security as a whole? So if you look at today world, software is everywhere in society, right from your, let's say, your mobile devices, your watches, your car. Now they are having autonomous car, in airplane, satellite, in your house. So software is everywhere. And looking at the current data from this website called Podspeaker, we have seen that a lot of attacks happen in recent year or even this year. So there is attack on French government visa website, which exposes applicant data. This is very recently, last few months. And there is a data breach at New York University. And there is also a school district breach, which is happened in the month of September. And then there is also a breach or a kind of attack at Singapore Eye Clinic. So if you look at these news every day, or if you can check in the website every day, there are always some sort of cybersecurity attack happening, and the attacker keep on attacking and try to gain access to private information so that they can use it for the benefit. Now, what is software security? So software security basically kind of way of secure the software in such a way that the attacker cannot attack it. And a common entry point for attacker is software vulnerabilities. So if you have vulnerabilities in the software, then that is the common entry point for an attacker. And the job of software security researcher, or anyone who protect or anyone who code the software, is to finding and fixing these vulnerabilities before an attacker find them. So it is kind of a cat and mouse game that you have to kind of find them first and then fixing them before the attacker discover that you have the software vulnerabilities in your software. So this is a kind of a game and unending process Like a security researcher will keep on looking at it, and also the attacker in his own space will keep on looking at it, and who finds first, that is kind of the winner, and try to protect um, the software infrastructure. Now let's look at this small motivating example, which is the buffer overflow. This is kind of a small code. Basically, it will not be there in the next few slides, but this is very, very important to motivate you. One very simple example of software vulnerability. So given this small example C program, you have this character buffer, which is a variable buffer of size 4, which is declared at global scope. And you have this access is a variable which declared as an integer. And then this is a main function. And this program, what it does, it takes the input from the user and then copy that input into this buffer, which is of size 4. And then it's basically compare that input with the secret, that is the pass. So if a user input pass, then it will say access is equal to 1, that is the access has been granted, that you are authenticated into the system. And if the access is 0, then this comparison did not pass, basically not authenticated. So if the access is true, then access granted, and you have a kind of a root access, and then else you have access denied. So this is a very simple hypothetical example. Maybe in real life application, you would not implement it like this, but this is just to demonstrate the small example of software vulnerabilities. Now, if you run this program, let's say I compile this using GCC, and I run this program, I say buggy pass, which basically the pass the exact string over here. You will have, of course, access granted, that you have the root access, and this is a genuine, password where you supply it to the system, and indeed pass is the secret in your system. So this is fine, this is okay, everyone happy, they are getting access into the system with the correct password. And now another test is if I provide A, B, C, D, of course, it will be access denied. So this is A, B, C, D, and then the string will basically take from the input, which is from the first argument, and then it will copy that input into this buffer, and this buffer is basically of size 4, and it will do a string comparison with the buffer and the secret. And of course, this will not be equal to 0 because the string ABC is not equal to pass, and it will basically print access denied. So this is happy, your program worked as expected, and you feel like, okay, this is the correct program to implement. I can ship this to production and let user use it to authenticate their credential. But the problem is, if for example, if you provide uh, a string like this, A, B, C, D, E, F, G, H, I, J, K, surprisingly, it is access granted and root access. So what is the problem here? This is the buffer overflow problem. Now, if you look at this, why this is happening is because when you provide A, B, C, D, E, F, the number of characters allocated for this buffer is 4, but you provide for more characters. So basically, it copy from this input into buffer, it overwrite this character for the next access, which is basically the integer. And this will basically make the storage or the memory location of access to have some other values, which is basically E or F or E, F, G. And when this comparison happen, it basically access granted. So this is one classical example of buffer overflow. And it's still happening if you compile this in your compiler, but there are some protection you can do for this type of attack. Now let's look at the background. So I've talked about the motivation example that if you have a program like this and there is some kind of attack that an attacker can do by simply provide a long string of text A, B, C, D, E, F, and you have a root access to it. So this is bad. Now, we have this example. Now let's look at some of the background we need to know before moving to fuzzing. So let's look at some of the background. I call it a control flow graph, is the way of representing a program into some other form. So you have a program like this, and then this program is basically input an integer, and then it will check whether that number is an even or odd by simply using num modulo of 2 is equal to 0. Then this will be an even, else it is an odd. A very, very simple example to check whether an integer is an even or an odd number. So what is a control flow graph? So a control flow graph is basically a representation where you have the information of the control flow of your program. And if you start your programming language by drawing flow chart, and this is one kind of a flow chart basically. So let's split this. So you have this in print and scanf. This will be one section of the program. And if this is true, then you go to that number is even. And if it is false, then you go to, you print this statement called that number is odd. And then finally, these two statements divert to this return statement. So you have this control flow graph. So this is the control flow graph. You start with these, and then if this condition is true, you go here. If it is false, you go here. And then you finally merge in the last, in the return statement. So very, very simple. This is a very simple control flow graph. And then let's look at what these are. And we can say that this block of code is basic block 1. And this block of code is basic block 2. This block of code is basic block 3. And this block of code is basic block 4. So we rename it to, we call it basic block in this section of code. Now I can have these, I can remove this code just to make sure that it is easy to read. I can say that the basic block 1, if it is true, it goes to basic block 2, and then merge in the basic block 4. Similarly for this. So this is a control flow graph representation of this program. Now let's look at what is an execution path. So an execution path is a path. Execution path is a part where the program flows. That is, for a given input, let's say an input 4, the program flows like start with the basic block 1, then to basic block 2, and then to basic block 4. And this is part 1. Now I can take another input called input 3, and this will execute basic block 1. It will go to the false part. It will execute basic block 2 and then basic block 4. Let's call this part 2. So what is an execution path? An execution path is a possible flow of control of a program. So if you look at this, you have two parts, part 1 and part 2. Now we have two input. I call this as test case. So the first one, which is the yellow line, will be the input number 4. And the second one, which is in the red line, which is the input 3. And I call this 100 code coverage because with these test cases, it covers all the code, right? It executes all the code. And indeed, these test cases obtain 100 code coverage. So again, what is a code coverage? Code coverage is a fraction of code cover by some by a test cases. So in this one, you have 100 code coverage. So software testing. Now we'll look into software testing. Software testing, basically, you need an input into the program, and then you need to look into whether that program, the output of the program, pass or fail. Now, for example, in the last program, the input, let's say 4 and 3, and we check whether it is pass or fail. You may ask a question, how will I know that the program is correct, that is pass or fail? That is very, very important question. We need what we call the test oracle. So test oracle is basically a ground truth information of the output of the program, and you need to have the knowledge whether that output is correct or it is incorrect. So what is a test case? In simple term, a test input plus the test oracle. So when anyone gives you the test case, you basically need to have this test input and as well as the test oracle. So a very, very important concept that in software testing, you basically need a test oracle. There are many types of test oracle, which I will not be discussing today. But if you are interested in software testing, you need to study, you need to look at many ways of many ways or many methods of getting this test oracle. So we have this idea of software testing, that is given the input, probably you have written a program and then give it to one of your students and tell them to write test cases for you. That is, okay, student 1 will come up with number 3, student maybe other student will come up with multiple test cases and then try to test your program. Indeed, this is a good way. This is what the current software system or the companies used to do, is manual testing. But a more robust way is, can we automate software testing? So we have what we call automated software testing. That is, given the test cases and you have a program running, you kind of wanted to have this test case trigger software vulnerabilities. So suppose you have, this is a control flow graph I discussed before. This is a basic block 1, basic block 2, basic block 3, and deep inside one of these basic block, you have a bug. Probably you have some kind of buffer overflow or probably heap overflow, which is basically similar to a buffer overflow, but in the heap space. This you need to look into what is heap overflow and use after free. That is when you use a memory location after it has been freed. So these kind of vulnerabilities exist somewhere in the program due to programming error or due to some other, if the compiler did not check it, did not check this kind of vulnerabilities. So let's say you have this bug somewhere in your program and you wanted your test cases to reach that location such that it will trigger these bugs, so that you know that, okay, there is a bug in that basic block. So you kind of wanted to have these crashes. So in automated software testing, to generate these test cases, you have what we call symbolic execution. So symbolic execution is basically trying to generate this input of the program by symbolically analyze the program. So the symbolic execution will try to generate all possible inputs that touches all these basic block if they are feasible. So I will not talk, if when I say feasible, it means that there exists a path from the start of the program to that location of the program. So to generate test cases which cover almost all the part in the program, people uses symbolic execution. And one example of this very, very popular symbolic execution is the CLI framework, which is available open source. And you can use this CLI to generate test cases for you. And the problem with this is symbolic execution is quite expensive and time consuming. And if you have a large program, large code base, you will end up waiting for the CLI to generate this test case for you. And the other approach, which is less expensive and quite simple, is fuzzing. So fuzzing is in the middle of this symbolic execution. It uses lightweight approach to generate these test cases, sometimes randomly, sometimes with the feedback from the program. So what is fuzzing? Now we come into the core concept of fuzzing. Now we know what is a control flow graph. Now we know what is execution path. Now we know what is a code coverage. And then we'll use this concept to understand what is fuzzing. So fuzzing is basically throwing random input into the program and see whether it crashes or not. So that is very simple. You have a program, you throw random inputs. So it is like you throw anything into the program and hoping that it will crash. So that is fuzzing. So let's start here. So the test generation here is to generate random inputs and then send it to the program, and the program execute that. And if there is any violations or any crashes, then this is kind of a bug, which will place it in somewhere in your folder. That input is a bug, and then you kind of look it for later reproduction. And then if there is no violation, you continue and generate a new random input and then feedback into the program. So this is a process where you keep on doing these till your time. You can set a timeout of 24 hours. You can set a timeout to 1 week, or there are software, especially for Google's, where they continuously fuzz the program and continuously run the program to find software vulnerabilities. So this is very simple, right? You have a program, you generate random inputs and then throw it into your program. And if it violates, then it is a bug. If there is no violation, then you continue fuzzing till you have no resources left at your disposal. So that is very simple. Now the challenges for this fuzzer are, sometimes if you generate random inputs, they might not be able to penetrate into your program. That is, you start here, suppose you generate random seed, it basically go into these check and then an N. It never goes into this side, which have a very deep code part. And this is one of the biggest challenges in fuzzing. So it's very hard to find deep bugs. So if your bug resides deep inside your program, then it is very difficult to trigger this bug. So the root cause of this is fuzzer generated inputs cannot bypass complex sanity check in the program. So there are programs where they check, for example, a very like in the example, I have the check of the password. This is kind of sanity check, and it is very difficult for the fuzzer to pass that check. So let's look at a type of fuzzing. So we know that what is fuzz testing. Now we know what are the challenges for the fuzzer, and then we'll see how researcher come out with different type of fuzzer to address the problem. So we have this random input generator, and this will produce us what we call test cases. And this is the program, and this is a black box. When I say black box, it means that you have a program, you know only the input and the output. You have no knowledge about the internal of the program. You have no information about the control flow graph, as we discussed in the last few slides. You only know that this is the input and this is the output, and you kind of monitor the program whether it crashes or not. So this is black box fuzzing. It's similar to black box testing. You have no knowledge of the program internals. And gray box fuzzing is you have some knowledge of the program internal, maybe the basic block information, which part of the basic block it's already been executed, which part of the basic block is still not yet been explored. So these kind of information you have in a gray box fuzzings, and you have this kind of feedback loop to this guided random input generator to tell the generator that this is a kind of interesting seed or interesting input, you mutate it. We'll talk about mutation in few slides. So basically, in gray box fuzzing, you have some knowledge of the program, not all. Basically, you have only a few, like the control flow graph or the basic block, and then you send that feedback to this guided random input generator to generate this test case for you, in the hope that you can trigger some bugs, and you monitor the program. And in white box fuzzing, this is, you have complete knowledge of the program. You have the source code with you, and you can analyze this program, and then you can pass this information to this input generator to generate test cases. This is one example you can use using the symbolic execution to generate test case for you. So these are the three major types of fuzzing. You have the black box, you have the gray box, and the white box. The black box, you have no information about the program internal. The gray box, you have some information about the program internal. And the white box, you have complete information about the program. So there is a trade-off here. The black box, you have no internal at all. You have only the basic input output. And in the gray box, you have some internal, for example, the coverage information. And the white box, you have all internal. So black box, it's a quite ineffective, whereas white box, it is inefficient, very costly to do. And in the middle of it, it's a gray box, which is kind of efficient and effective. So this is the major area where people propose a lot of ideas in this section because it is quite efficient and effective. Now let's look at gray box fuzzing. Since this is the research area I'm working on, the gray box fuzzer, I'm going to talk about the gray box fuzzings a little bit in details. So this is one example of a block diagram in gray box fuzzing. Let's say you want to fuzz a JPEG encoder or a small application which the input is images. And what it does is, given this input corpus, which is your initial input data, that is your JPEG files, and then you pick that input. Let's say this is the input in hex, and you use this mutation. Mutation is basically just altering bits or altering this data. For example, if the input is AA, I can simply alter CC. This is just a very simple mutation. I can maybe flip C to A, flip C to Z or anything. I can just change this file randomly using some kind of what we call mutation operator. And mutation operator are very simple. And you can even add this to, multiply this to, subtract this to. So this is kind of random. You can do, you can have your own mutation rules, and then you can see whether it is effective or not. So given this input, you mutate it, that is, you change it to this, and then you send this to the program. The program will execute this part. And if somehow it trigger the place where there is a bug, then crash found, and then you store this input file for further processing. That is, you need to look at what's happening, or we call it bug reproduction. And again, for this next input, you again mutate this section of code, that is D6, you make it AA, very simple, just change it randomly, and then you execute it, this no bug, no crash, pass, and then this is no bug and crash, and it's pass and pass. And if you look at these, some of these execute a different basic block, that is different part of the program. And if this code coverage increases, then I will pick that input as interesting input, right? So this is very important. That is, when there is an increasing in code coverage, then that input is taken as interesting seed, which basically put back again to this input corpus, and then further mutate and then run again and again. So this time will be maybe 24 hours, 48 hours, or can be several months. And if there is no code coverage, then I will discard this input. So very, very simple. So you basically take the input from the input corpus, you mutate it, that is, you modify bits of the or anywhere in the input files. You run it in your program, and you check whether if it's covered. If the code coverage increase, if the code coverage increase, you keep that input for the next mutation. So state-of-the-art fuzzer are these are the available state-of-the-art fuzzer is the American Fuzzy Lob++, which is the state-of-the-art, which we are currently using. and we are kind of benchmarking with this one. So you can download it from GitHub and then pick a small program in your in any program and try to run the fuzzing. And Google has this OSS Fuzz, which is a continuous fuzzing for open source software. It is available on GitHub as well, OSS Fuzz. So these are the two kind of state-of-the-art fuzzer. There are many more available online, but they are not very much popular and not well maintained. But this is very easy to run. The American Fuzzy Law Plus is very easy to run. You can download it, compile it, and then you can quickly set up this fuzzer in a day or two. And then you can start fuzzing and see the how you will be able to find bugs or not in the program. And one very example is getting into computer system security. There is one very good resources available online, which was available last year by this Arizona State University. They open source the whole the whole course of computer system security. They call it PWN College, and here you can you have all the modules regarding the fundamental of computer system security, starting from the assembly refresher till binary reverse engineering till kernel security, which was available this year. And you can use this platform to practice your cybersecurity, right? So you can become, a white belt in cybersecurity and a blue belt as well. So once you enroll, no, this is free of cost. You can enroll into this course and try to complete their challenges. And then once you completed a few challenges, you can email Jan for this the kind of a certificate that you completed, and Jan will give you a kind of a blue belt or a white belt, depend on your progress. And in YouTube, you can go to Life Overflow, which is a very nice channel for learning cybersecurity. And bonus is cybersecurity. You can earn you can earn what you call bounty. You can go to HackerOne, Bugcrowd, Integrity, Yes We Hack, and Synax. These are the platform where you can hunt for bugs, and then you can earn money from this platform. So for students, especially if they are very much interested in cybersecurity, then they can study the concept first, maybe from these, and then they can start looking for bugs in this platform. And if you are good at it, you can make a living out of this platform. And thank you for your attention. That's it. Thank you very much. And I'm open to question and answer.
Yes, thank you so much,
I'm not able to hear anything. If anyone having question, kindly. Okay.
Hello, can you hear me?
Yes,
Can you
yes, clearly.
Okay, sorry, I got disconnected. Yes, so that was a very valuable insight on how we can actually test out our software system, our computer system. So yes, the students can actually relate very well to what you had explained, Doctor, like how testing should be done. What does it mean by code coverage? Because majority of the time when we are working on a system, we are looking at, mostly we looked at the surface area. Say, for example, we are trying to put up an input, and the moment we get a correct output, we thought that our system is correct. So we tend to go with that system. But then, as you had shown us clearly, that see many things actually going on in software security. That I mean, if you're trying to build a system, if it can, if it has a majority coverage uh, of your system, then we can maybe take that as a successful system. So yes, any participant, anyone, can you hear me? Am I audible?
Yes.
Okay. So yes, participants, now we have the question and answer sessions. So if you have any question for Dr. Bernard, you can put it up in the chat box. Okay, so in the meantime, okay, we have one question here. Uh, what are the other real life applications of fuzzing?
Okay. So this question from El Karumruj. Okay, what are the other real life applications of fuzzing? Okay, so real life application of fuzzing is, let's say you have a program basically in your computer. Let's say it is a PDF reader, right? I think you know about PDF reader. I think everyone, when you open a PDF file and you need a PDF reader. Now, that PDF reader basically reside in your computer, or it can be in your Android application. So if you are having an Android device, you can have a PDF reader installed in your Android device, maybe Acrobat Reader, maybe Foxit Reader, or other PDF reader. And if somehow this PDF reader contains bugs, that is, you have a PDF that trigger the bugs, right? There is some problem in the PDF reader. You have it somewhere in your program, and you somehow able to craft one input, that is one PDF, that basically crash that PDF reader. Then there is a problem. Then you can write what we call a shell code or an exploit that crash the program and then inject code into that crash program, and you have access to that computer. Okay, in which and when you have access, you have the same access privileges as the Foxit reader running in your program. Okay, so this is very dangerous, and it has already been found in many PDF reader. Recently, last few years, there is a PDF reader which basically contain this kind of bugs, and they have to patch it quickly because a lot of Linux machine having this PDF reader installed automatically. And last year, even the Linux Ubuntu skip the default installation because the maintainer of that PDF reader did not fix the bug. So it's very important. And if you look at Google, what they do is, for all of their products, they run fuzzing continuously, because at the end of the day, they need to find bugs quickly as possible. So they kind of run this fuzzing quickly and try to find bugs. So this is one real life example. So if you look at your Android devices, you have many applications, and if one of them is having bugs, and if someone, the hacker, able to find this kind of bugs, and they are able to have an input that crashes that bugs, then they can easily send input to you or any targeted device, and then they can simply crash and exploit and able to gain access to your Android device. Thank you. I hope I answer your question. Okay, so next question, how long should we fuzz? Interesting question. I really like that question. Why? Because it is very active in our research community. So this is very nice question. How long should we fuzz? So there is a paper called "When Do We Stop Fuzzing" by Marcel Baume. He is a German scientist, a computer scientist. He has done his work on fuzzing as well, and very successful in finding many bugs. He has a kind of done of analysis is in terms of statistically when should we stop fuzzing. So usually people first for 24 hours, which generally for many application, but you can even first for months, depending on the availability of your resources. So there is no, or when you have a code coverage of 100%. So when you have a code coverage of 100%, basically, if you think that you can stop, then you can stop, but still 100% code coverage doesn't mean that you have zero bugs. There are still bugs depending on the input, which may trigger the bugs. So this is very, very nice question. I really like this question. How long should we first? Because this is what the current state of the art community trying to address, to have a concrete or a quantitative idea of when to stop the first. So this is still not clear in the research committee as well. So very good question. Thank you for Nishita for this nice question. So any other questions?
Hello, sorry, I muted myself. Dr. Bernard,
Yes.
yes, I have a question. Like, what is the minimum code coverage we can expect when we are doing fuzzing?
Uh, you cannot you cannot say the minimum because depend on your test cases. So it's up to your test cases. So if you are fuzzing using a black box approach, then possibly you will not get good good coverage as well. So it's all depend on your test cases. We cannot say what is the minimum, what is the maximum code coverage. We never know, right? So only if you use some kind of those white box testing like symbolic execution, then you can at least guarantee that you can have 100 code coverage. Depend if the symbolic execution able to generate those inputs for you. But in terms of fuzzings, it's basically what we evaluate is we check the code coverage at the end of the first. That is, what is the progress of the fuzzing. So, for example, if I fuzz for 24 hours, what we did is we kind of monitor how fast the code coverage is being progress. So you kind of have a graph saying that, okay, at 1 hour code coverage is at 30%, at 2 hours code coverage is say 50%. So you can have this kind of a loop, kind of a graph showing that you have this code coverage progressively till 24 hours. But at some point of time, the code coverage will stay, at constant, where you will not be able to find more test cases that will cover more codes. So yeah, there is difficult to say what is the minimum, basically.
Thank you. So any other questions? Okay, so we don't have any further questions, then let's proceed ahead. So yes, thank you so much, Dr. Bernard, for the time that you have given, the time that you have make yourself free in this part for to deliver this particular interesting session to us. It will open up new ways and means for the students to look at a computer system or to look at even their small programs on how to actually secure them internally. So yes, thank you very much,
Thank you
Dr.
very much.
Bernard.
Thank you very much, Professor
So,
Melvin,
so with
for
that, just
inviting
hold on.
me.
Let me just share my screen. Okay, so as a mark of immense gratitude and appreciation to you, Doctor, we, the organizing committee, present this e-memento to you, and we wish you the very best in your future endeavors. Thank you so much, Dr. Bernard.
Thank you so much, Professor Melvin, and thank you very much, the principal, vice principal, deans, and the head of the Department of St. Edmund College, and especially the Department of Computer Application. Thank you very much for inviting me, and looking forward to meeting you soon, or maybe talking to you soon. Thank you very much.
Yes, definitely, Doctor. We will be happy to meet you personally. Okay.
Yes.
So yes, thank you so much. Now, with that, I would like to welcome Ms. R. Karim, faculty of the Department of Computer Application, to deliver the concluding remarks.
Good afternoon, everyone. I hope I'm audible.
Yes, you are.
All right. Okay. So thank you so much, Dr. Bernard, for taking out your time this morning for you and afternoon for us for talking about fuzzing. Now, our students, I'm very happy that our department students who are attending today are the 5th semester, 3rd semester students who are working with software, who are learning software engineering and building software. So it has been a very great time for them to listen from you about fuzzing. I would like to put on record like what Dr. Bernard had said, that software is everywhere. We all know that software is everywhere. We are using it in everything that we are doing these days. It's not something that is not common anymore. But when we tell our students also, you know, when they build the software, they are so lost in the features and everything, which is actually the requirement of the software. But releasing it without proper testing is what many do. So that is something that really will have many drawbacks for the software, and also will rate the software very low, because when it goes without proper testing, we understand there are going to be a lot of bugs, a lot of errors, and a lot of problems happening for the user. So I'm very happy, sir, that today you've put up this topic and made our students aware of fuzzers. You've shared with us the online resources, then the different fuzzers available on GitHub and all. I've taken screenshots. I'll surely be sharing it with my students so that, you know, they can enhance their software by adding up to whatever you have taught today. And then I'd also like to thank you for telling us about the challenges that are there, like, you know, shallow coverage that you've talked about. It's actually something that as software developers in the field of computer application, we all know shallow coverage is something that we all do. Sometimes maybe to save time, sometimes maybe we don't want to spend so much of effort. So thank you, sir, for bringing that also to our notice, and also for talking about the vulnerabilities that are there, for talking about gray testing. Our students have heard about black box, white box. Today they've heard about gray testing also. So thank you for that also. And then I think it has been a very great experience, a very knowledgeable session for all of us that you've taken right from the basics of how software are used to the advanced level of going to the code and the different testers. I'd really like to put my gratitude from the entire department, from the students who've attended this. We have had a very benefiting session. Thank you, sir. Over to you, Sir Melvin.
Thank you so much, Miss. So, yes, dear participants, with this, we have come to the close of this session. And to wrap up, I would like to call our student, Nishita Malakar from the 5th semester, to give us the vote of thanks.
Thank you so much, sir. A very good afternoon to all present here. I, on behalf of St. Edmund's College, Department of Computer Application, feel immense pleasure to propose a vote of thanks. I take this golden opportunity to thank our today's speaker, Dr. Bernard Nongpo, security researcher at Celis University, Paris, Saclay, France, for such a wonderful session. Thank you, sir, for taking up the topic that really matter in today's age and time. I extend my gratitude to the respected principal Dr. Sylvanus Lamare and respected vice principal Monathesh Chakravarti for encouraging us to achieve many endeavors. Thank you, sir, for appreciating us and encouraging us. It is my pleasure to thank our Dean, Dr. B.W. Nongbri, not only for participating but also for guiding us to a beautiful life. Thank you, ma'am. I would like to heartily thank our secretary, Dr. Brother Raj Narona, for enlightening this event with your presence. My sincere gratitude also goes to the HOD of BCA department, Ms. Sharmishta Deb, for encouraging us and giving us this opportunity to organize such events. I would also like to thank all the HODs of each and every department for attending the webinar. I would further extend my heartily thanks to all the teachers of BCA department for organizing the event. This was really helpful for us to know so much from the speaker. I would also like to thank all the teachers for enlightening this webinar with your presence. My deep sense of appreciation and thanks to all the participants who chose to be live with us and attended the webinar with great enthusiasm and making it a successful event. So we have come to the end of the webinar. Thank you all for being with us this afternoon. Have a wonderful day ahead. Thank you.
Thank you,
Over to you,
Nikita.
sir.
Thank you very
you.
much, students and everyone. I hope you will take something from the lecture. Thank you very much for attending.
Thank you so much. So before we close this session, I would like to request all the participants to kindly turn on their webcam so that we can have a screenshot, a group photo. Kindly turn on your webcam. Yes, thank you so much, everyone. A feedback form will be sent to you via mail. So have a great afternoon until we meet again next time. Thank you all. Bye-bye. Have a great day.